Today we're going to take the day to review some of the basic exponent properties that you learned about in Algebra 1. In front of you, you will find a foldable that you're going to fill out as we go along. Unless you're not in my class, and in that case, you can just take notes on a piece of paper or something to review. Okay, there's a couple of basics we need to remember is on exponents. The large number at the bottom is what we're multiplying together. The small number is how many times we're multiplying it. We call this the base in the exponent or the base in the power. 2 to the third, for example, is 2 times 2 times 2, which is 8. Now, there are a couple things we have to remember dealing with negatives. Negative 2 squared is negative 2 times negative 2, which is a positive 4. So the basic rule is if we have a negative number in parentheses to an even power, the answer is positive. Let's look at a negative number in parentheses to an odd power. The result is negative. So a negative number in parentheses to an odd power is negative. Now the last rule is if there are no parentheses, and this is what gets you guys sometimes mixed up when you're using your calculators. Negative 2 to the fourth. What this means is 2 to the fourth, which is not 8. That's a typo. That should be 16. And the negative in front means we multiply by a negative. So this should be a negative 16, not a negative 8. Let's look at a few other things. Okay, I'm going to slide this up so you're not looking too far ahead. Basic rules. If there is no exponent, the exponent is a 1. For example, x is the same thing as x to the first. Any base to the 0 power equals 1. So 6 to the 0 is 1. X to the 0 is 1. Or if we have a quantity to the 0 power, it is also 1. Flipping on. Page 3. Basic exponent rules. First rule we have is called the power to a power. Basically, the rule is if there is only a one base with two powers multiplied together, we multiply the exponents. So x to the third to the second is really just x to 2 times 3, which is 6. Reason being is that x to the third to the second means that we're multiplying x together 3 times 2 sets, which gives us x to the 6th. Now, if we don't have power to power, we multiply. So if they're the same bases, we add the exponents. Because the difference between the previous example and this one's saying x to the third times x squared. And therefore, we add. But the catch is they must have the same base. Let's look at a few. A to the 5th to the 4th. Now you can just do this on dry erase or on a piece of notebook paper. I see power to a power. So this is really saying 4 sets of 5. 5 times 4 is 20, so we get A to the 20th. Same way we can deal with other numbers. 4 times 2 is 8, so it's 6 to the 8th, which if you wanted to multiply that out, 6 to the 8th is a very large number. It is 1,679,616, which you can refer to your exponent table. Now the other one was that they have the same base. We add the exponents. So 9 to the third plus 9 to the 5th means I have not 3 9s multiplied together with 5 9s multiplied together. So what we do is we add the exponents. 3 plus 5 is 8. Now 9 to the 8th is really big, so I'm just going to leave it alone. Z to the 4th times Z to the 10th. Same base, we add the exponents. 4 plus 10 is Z to the 14th. So those are some basic problems. Okay, now let's look at some more interesting problems. So this you can flip ahead in your foldable, so fine. Okay, it says combined rules. It's on page 6. So when they're combined rules, I'm going to show you all the steps, but you can condense steps, and we'll talk about it as we go. So the first thing you want to do whenever you're doing a combined rules is you want to give, in this case, everybody the third power. So what I do is I separate the coefficient from the variables. Negative 2 to the third, and then xy squared z to the 8th, all to the third. After that, I use my basic rules. Power to a power, I multiply. Now, if something doesn't have a power, like the x here, the power is a 1. So it's 1 times 3. So this becomes 2 times 3. This becomes 8 times 3. Now, once I've done so, I simplify and combine. Negative 2 to the third is negative 8. 1 times 3 is 3. 2 times 3 is 6. And 8 times 3 is 24. Now, Mrs. Dorn, do I have to show all these steps? No, this is just my mental process. This is what I'm doing. I took negative 2 to the third and got negative 8. Then I multiplied all my powers, and if something doesn't have a power, it's a power of 1. And that is where I got the other values from. Okay, let's try another one, going over to the next page, which is page number 7. Here is another one where we're just multiplying. So remember to multiply, you multiply the numbers and you add the exponents. So first I'm going to separate them. I'm going to take the negative 2 and the 3 apart, which leaves me with my variables and my variables. Now I multiply my numbers. I get negative 6. And then I'm going to add by exponents. Now remember, if there is no exponent, the exponent is a 1. Excuse me. So a to the third and a to the first makes a to the 3 plus 1. B to the second, B to the fourth is B to the 2 plus 4. And C to the first and C to the first gives you 1 plus 1. So my final answer is negative 6, A to the fourth, B to the 6th, C to the second. Let's try a couple more of these. So grab out your dry erase or whatever you're going to use to practice. The first one is a power to a power. So I'm going to try to combine some steps. I'm going to go power to a power. Now, power to power states everybody gets the power. So 8 is going to get the power. So it becomes 8 to the 5th. 5 times 4. 5 times 4 is 20. 5 times 3. 5 times 3 is 15. 1z times 5 is z to the 6th. Now all I do is get rid of the number in the front. So I use my exponent table or my calculator and look and see what 8 to the 5th is, which is 32,768. And I am done. Let's take a look at another one. Now this one's a little bit trickier because it's combining two of them. It's power to power and multiplying. So when you encounter this, normally in order of operations we do parentheses and exponents first. So I'm actually going to do the left-hand problem first. So I'm going to do 3 squared. Power to a power you multiply. It's like distributing. 2 times 4 is 8. And then 2 times 1 is 2. Then I'm going to simplify it. 3 squared is 9. And then I'm going to bring down the rest of my math problem. And now that I have no more power to powers, I multiply the numbers and add the exponents. 9 times negative 2 is negative 18. 8 A's and 3 A's give me 11 A's. And 2 B's and 1 B give me B to the third. And now we've done both of those basic concepts. Let's move on a little bit. We're going to briefly talk about dividing. So for dividing, you're going to treat the bar as a division sign, as a subtraction sign. So for example, b to the fifth divided by b to the second. What you do is, since they're the same base, you subtract your exponents, which is b to the third. Now, I don't always use the idea of subtraction. I sometimes just ask, where do I have more at? If I have 5 b's on the top multiplied together and 2 b's on the bottom multiplied together, where do I have more at? I have 3 more b's on the top than the bottom. Now, this does work either way. So if I have a to the fourth on top and a to the ninth on the bottom, this one's actually what we kind of call bottom heavy. You've got more on the bottom. Okay, you could deal with the negatives if you want. But basically the idea is, since I have 5 more A's on the bottom than the top, I write a to the fifth on the bottom. And I put 1 as my numerator. Okay, let's try a couple of these real quick. So on fractions, what you do is you simplify the numbers in front to begin with. 4 over 10 are just numbers, and 4 over 10 reduces to 2 over 5. Now you can subtract, or you can just ask, where do you have more x's at? I have x to the 8th on top and x to the 3rd on the bottom. So I have 5 more 8's on top, x's on top than the bottom. Y to the 5th is on my numerator, y to the 9th is on my denominator. So I have 4 more y's on the bottom. Let's try one more. Okay, my numbers in front. Negative 36 over 18 reduces to 2 over 1. Now you can put your negative in front or in the numerator, 2 over 1. Where do I have x's more at? I only have x's in the numerator, so they're going to go in the numerator. And where do I have more y's at? I have more y's in the denominator. I have 5 more y's in the denominator. So this video has covered what do you do when you have power to a power, or when you're multiplying, or when you're dividing. Video 2 will go in more depth to negative exponents and so on.